the network is like not directly connected to our router. In the case there is a WAN link in between two routers, in that situation we will be using some kind of routing protocols. So normally for routing we can use either static route or a dynamic route. So static route means if we are having less number of networks, we can go for a static route. If we are having like 10 or 15 networks, then we can use static route. But if we are having more than that, we will be preferring dynamic routes, dynamic routing protocol. So in the case of static routing, we need to configure, if we are having 15 routes, 15 networks, we need to configure all the 15 networks in all of our routers. And if you are having like 10 different routers, we'll need to configure the 15 routes in all these 10 routers. That is totally a count of 150 static route we have to configure. So that is possible, but if you are having more than like 15 or 20, then we will be going for dynamic routing. So if we are going for dynamic routing, then we will be publishing only what we are having. If in my router I am having 2 networks, then I will be publishing only whatever I am having. Those 2 networks only I will be publishing. And likewise, all the other routers, in all the other routers, those routers will be also configured to send out their connected networks. So we won't be, there is no need that we need to know all the 15 routes or 20 routes. We need to know only whatever we are having. Okay, so in the case of internet, we are having like around 9 lakh networks are there. So instead of configuring all these 9 lakh routes, we will be configuring only whatever I am having. So through this routing protocol, we will be getting all these 9 lakh routes from our WAN connection. Okay, for that purpose, we will be using dynamic routing protocol. So if you are checking for if you are going to differentiate between a static route and a dynamic route, for static routing, it is a bit easy to configure, and it is manually configured, and if there is any mistake when we do the manual configuration, then that will affect all the routing. But for routing, if we are using a dynamic routing protocol, any protocols are used, then those protocols will be collecting all the details from the neighboring devices, and that networks will be entered into our router. So there is no need of a manual configuration or manual understanding of all the networks which are there in the other routers. We will be getting it automatically. So that is a main difference between a static route and a dynamic route. And static route we will be configuring only if there is less networks. If there are more networks, then we will be using dynamic routes. Then the next difference is, if you are going for static route, there is no CPU utilization in the router because we are manually doing the configuration. If you are going for dynamic, and if you are configuring any one of the routing protocols, then the CPU will be making some calculations, and that needs CPU, like the router CPU. So the CPU utilization might go high when we are using dynamic routing protocols. So these are the main difference by using static and dynamic. For dynamic routing protocol, there are different dynamic routing protocols. One is RIP, Routing Information Protocol. Then we have IGRP. Then the next version of IGRP is EAGRP. Then we are having OSPF. Then the protocol that is used by ISPs, it is BGP, Border Gateway Protocol. So now we'll be checking on RIP and IGRP. So whenever we configure a routing protocol, we will be having an administrative distance value. So the administrative distance value, with that only we will be understanding which routing protocol we have configured. For RIP, we are having an administrative distance value of 120. For IGRP, the value is 110, no, 90. Then for OSPF, it is 110. And BGP, we are having two admin values. One is 200 and other one is 20. So if we have configured two different routing protocols, say I have configured EIGRP and RIP, and both of these routing protocols have given me the same network. So in that case, the router will be confused which route it has to take, whether the route came from RIP or the route which has come from EIGRP. In that case, it will check for the admin distance value. Whichever is having the lowest administrative distance value, it will be taking that route. Okay, if EIGRP and RIP is configured, the routes which are received by EIGRP, that only it will be taking. Both the routes will be shown in the routing table, but the best path will be EIGRP route because it is having a lesser administrative distance value. So the lesser administrative distance value means the calculation is a bit complicated and more reliable. Okay, let's go with RIP. The administrative distance is 120 and there is something called hop count. So RIP, what it does is it will be taking the best path based on the hop count. So when the route passes one router, it will add one. And when it passes the second router, it will add one more and the count becomes 2. So likewise, for each router it passes, it will be adding 1. So if I'm seeing as the metric value as 5, that means the hop count is 5 and that particular network is 5 routers away. Okay, that is how the RIP is calculating its route. So if I am having RIP configured and the same network, it is getting through two different paths. And one path it is having a metric value of 5 and the second one is having a metric value of 7. That time it will check for the metric value which is lowest. So the route which has the lowest metric value, that is 5, it will be taking that path. So for RIP, it will be the only thing it is calculating is the number of routers it has to pass to reach the destination. If one path is having 5 and the next one is 7, the path it will choose is 5. And the disadvantage for this is it won't check for the bandwidth, it is checking only for the number of hops. So if the best path it has chosen is 5 and the bandwidth there is like 1 Mbps link, it is a 1 Mbps link, and the next path which is having 7 hops is 1 Gbps line, even though it is having a better path, it will be choosing only the path which is having 1 Mbps because it is checking only for the number of hops. It won't take the next one, like it won't check for the bandwidth it is having, or it won't check for the latency. It will check only for the number of hops. That is a disadvantage for using routing information protocol, RIP. So RIP is having two versions, version 1 and version 2, and the difference between version 1 and 2 is like version 1 it won't support subnetting. Okay, proportion 1 will support only like the full network. It won't support VLSM, variable length subnet mask, and for proportion 2 it will support VLSM or whichever subnets we are using, like after, even if the network is subnetted, we can publish it through proportion 2. So mostly they are using proportion 2. Next difference is, whenever we are publishing a network through RIP, it will be using broadcast in version 1, and for version 2 it will be using a multicast address. That is another difference. And the another main thing for RIP is it will be using only 15 hops. That is, it can pass the routes only up to 15. If there is a network which is placed like 16th hop, it will be treated as unreachable, because this was the oldest routing protocol, and during that time there was not like a big network, so they have created it in such a way that only it can pass only up to 15. The 16th one will be treated as unreachable. So that is a major drawback of RIP. So we can, if we are having a small network, we can use RIP. Otherwise, we have to go for other routing protocols. That is in the case of RIP. And it is using an algorithm, Bellman-Ford algorithm. Both proportion 1 and 2, it is using Bellman-Ford algorithm. These are the main things of RIP. The next protocol is IGRP. So IGRP is Cisco proprietary protocol. That is, it was created by Cisco, and it will work only in Cisco routers. It is not there in any other routers, only for Cisco. The next version of IGRP is EIGRP. For the case of EIGRP or IGRP, it is using a bit more complicated calculation method. It is using 5 parameters. It will be checking for the link bandwidth. It will be checking for the load in the link. Then, like 5 different parameters are there: MTU, load, bandwidth, and two other things. Okay, all these parameters it will calculate, and then only it will be finding the best path. So this is the main difference from RIP will be checking only for the hop count. Here it will be checking for the bandwidth, then latency, then load, MTU, reliability, all those things, delay also. All these things it will be checking. That is the main advantage of when we are using EIGRP. But only thing is, we won't be able to use EIGRP and IGRP in other vendor devices. Like it will be working only in Cisco. If you are having any Juniper or Huawei devices, it won't work in those devices because it is Cisco proprietary. So next one is OSPF, Open Shortest Path First. So EIGRP and RIP, mostly we are not using EIGRP and RIP now. Nowadays we will be using only OSPF or like BGP. Okay, those are the 2 protocols which we are using now. OSPF means Open Shortest Path First. It is using a Dijkstra algorithm, and here it will be calculating based on, like, most of the calculations is done like 10 raised to 8 by cost. Okay, there is a cost calculation, and cost means bandwidth. That is regarding the bandwidth of the interface. Only this cost is getting calculated. So OSPF is the one of the main routing protocols which is used now. The administrative distance is 110. Metric value is called cost. Cost means 10 raised to 8 by bandwidth of the interface. So here also we will be configuring our networks in the routing protocol. That is, in router 1, we will be publishing whatever networks we are having in router 1, and router 2 it will be publishing whatever networks it is having in router 2. Likewise, all the routers it will be publishing their own networks, and there is a hello time interval in this, and with that hello time interval it will be passing on the networks hello time, and there is an update time is there, and during the update time it will be sending the update packets. And whenever there is any change in the network, suddenly it will be sending an update. Instead of waiting for this update time, it will be sending the routing updates suddenly. So if router 4 is having a network and that went down, suddenly it will be sending, like, router 4 is having a network and that is not reachable now. It will be sending out the information to all its neighbors, and from there it will be propagated to the whole network. Likewise, all will be updating their routing table. So this is what happening in routing protocols. Then we have BGP. BGP is configured in ISP side, and normally it is having two flavors. One is internal BGP and the next one is external BGP. So most of the time they will be configuring only external BGP. Internal BGP they won't configure. External BGP means how it is getting from one ISP to another ISP. If we are having HiPOINT network and Hurricane network, those are getting connected using BGP. Like HiPOINT network will be connected to Hurricane network through BGP, and through BGP the networks will be published from HiPOINT to Hurricane and from Hurricane to HiPOINT. That is using BGP only we will be doing. Even if you are not, if you do not want to use BGP, we can use a static route for configuring this, but better we use a BGP. So in most of the case, we are going for BGP only if we are having multiple uplinks, multiple ISPs to uplink. In that case only we will be using BGP. So what BGP does is we will be getting the full routing table from both of the uplink ISPs, and BGP will be calculating. If we want to go to Google, we have to follow which ISP, like Hurricane network or the other one. That calculation it will be doing inside. That is done by BGP. So if we are going for static route, we can select either one. Either we can choose Hurricane network or we can choose the second provider. So instead of doing it manually, we can go for BGP, and BGP will be doing the calculations and we will be getting the best path. For BGP, the route selection is done with the help of 13 attributes. So main thing is AS path. For each ISP, you will be having an AS number. For HiPOINT, we are having the AS number 21788. For everywhere, HiPOINT will be using 21788. Like we purchase the IPs from Apnic or Iron or Arin, we will be getting the AS number also from Apnic or whichever provider we are having. So we'll be purchasing an AS number from them, and even for India network also we are using the same AS number 21788. That will be dedicated for us. And using this AS number only, all the ISPs will be knowing from which ISP this network is coming from. For that purpose, we are using AS number. So that is a case of BGP. So normally only between ISP to ISP only we will be using a BGP. Otherwise we will be going for OSPF. And some situations they will be using EIGRP. So the other two protocols, RIP and IGRP, that is not used anywhere now. Only these protocols they are using. So these are the basics of routing. So if you are having any like doubts, you can.
I have a few questions.
Yeah. Yes.
So first, you told that if we have like less than 10 network, we're using static routing. Is it any better than dynamic?
Not that we can't use dynamic. We can use dynamic also, but if it is like 10 networks, then we can go for static routing because there are few advantages if you are using static route. That is, there is no CPU utilization in that, and 10 networks we can manually configure in all the routers. That is okay. Up to like 10-15 we can do that, but if it is more than that, we can better we go for dynamic.
Okay. So you told that EIGRP has some like several features. Can OSPF fully replace EIGRP? Sorry.
OSPF, see, EIGRP we can use only in Cisco. That is a Cisco proprietary protocol. So if we want to use a different vendor, then better we go for OSPF. And
like,
OSPF,
I mean, if we have only Cisco devices, is it better to use OSPF or EIGRP?
We can go for OSPF or EIGRP, but OSPF is having a few other features also, like it is an area concept. So if our network is a huge network and it is divided into like one part is in India and the next one is in US, like that, then it is better to configure OSPF, because in OSPF we can divide it into different areas. So we can mark it like one area, geographical region we can differentiate. That is why we will be going for OSPF in that case, if it is a huge network.
And last question, what about protocol IS? Is it better than OSPF?
ISIS, I'm not just done the configuration part, because it is a totally different thing to configure. Like it is having a different numbering system. Everything is different in ISIS.
Okay. Thank you.
I have done only in the practical session only I have done, but I have not seen any of them using ISIS, because it is a bit like complicated to configure that. Anything else? And even we can go for like some areas we can configure with EIGRP, some areas we can configure with OSPF. Like that also we can configure. There is nothing like the full network should be in one routing protocol. We can use different routing protocols also. Half of the network we can go with OSPF. Then for few areas we can use EIGRP. Few areas we can go for RIP. Like that also we can configure. And these all these different protocols we can exchange the routes from all these different protocols using something called redistribution. So redistribution, what it does is, if we are having a few routes coming from RIP, we can pass it on to EIGRP, and all the EIGRP routes we can take it to RIP. That is done by redistribution. So if you most of the routers are Cisco, and like 3 or 4 are different vendor. For all the Cisco routers you can use EIGRP, and the other vendor devices you can configure RIP or something else, and we can make these two communicate. that is also possible. We can use a combination of all these routing protocols. Have you done the configuration for this? If you want to do the configuration, then there is like Cisco packet tracer is there. That is done for all the CCNA topics. You can do use packet tracer. If you want to go advanced like CCNP, all those things, then you can go with GNS3. So GNS3 is that is a software, and you can use it as all the commands can work on GNS3. So
I have one more question about a process. I never use static routing, so I actually don't know. Do we have like priority in static routing, or how it works?
I didn't get that.
Like,
Can you?
Like if we have to pass to one device, how we manage static routing to that?
How many devices are there?
Like, for example, if we have one device and two paths for that device, how we manage static routing to that device?
One device and two patch code.
Two paths, yes.
No, those two are getting connected to where?
So like, for example, in dynamic routing, we have a metric, so we can choose better path. But what
Okay.
about like static
Okay,
routing?
static routing. Static routing, we can change value. Like if we are configuring the static route, there is something called administrative distance value at the last. So
Oh,
we can
okay.
change the admin distance value. Like for static routing, it is by default it is 1, and if we are giving the command IP route destination network, and after the next hop address, we can give a value. So instead of giving it blank, if you are using a value 2, then one route will be having a default value of 1, and the second route will be having a default value of 2. So whichever is having the best, like the lowest admin distance value, that path it will be taking.
Okay, thank you.
And if both are configured, both path it is configured, then it will be load balancing.
Okay.
So normally what they does is they will be keeping a primary ISP, it will be giving without changing the value, and the secondary ISP they will be using value 1, value 2. So whenever the primary link goes down, it will take the second path. That will automatically get. For that purpose, they will be using two different routes. And when we are configuring the static route, there is something called default static. So for destination, we'll be giving 0.0.0.0. So that means uh, whatever traffic it will be getting, it will be passing on to this next hop. So using only a single default route, that is what normally we does for the end devices, for the customer end devices. We'll be configuring them a default static route with 0.0.0.0. So that time what it does is whichever next hop it is having, it will pass on all the traffic to that destination, to that next hop address. From the next hop router, it will be using its routing table to route the traffic. So if we are an ISP and we are having few like all the clients, then all the clients will be passing on their traffic, their internet traffic to our router using a default route. And if we are having only a single uplink, we will need only a default route to pass on to the uplink. Say if we are having only hurricane network, then or before hurricane, we were having cogent, so only cogent. So we need only a single default route to pass on all the traffic to cogent. So from cogent, it will be having the routing protocols and it will be routing to different path. So if we are having only a single path, then we can use a default route. Anything else? Any other doubts? I think the configuration, like commands and all those details, Rashmi has given a document initially. The CCNA document, you can refer that document for the configuration. Just hold on, let me see if I'm having some configurations. See the configuration for static root. It is like this IP root. You have to go to config mode. From there, you can use this configuration IP root. Then this one will be the destination network address. Then the mask. Then you have to give the next hop address. So earlier I was saying about adding a value after this. So after this 192.168.20.2, you can add a number, and that will be treated as the administrative distance value of this particular static route. So in that way, you can use multiple path for static route. So here, if I am using show IP route, you can see this output, and here yes means static route, and this is what, like 192.168.50.0 network is there, and in the bracket you can see 1/0. 1 means the administrative distance value. The second one will be the metric value. So based on this administrative distance value only, it will be choosing which path it should take. So if 192.168.50.0 is having two different paths, one is having admin distance of 1 and the second one I have given it as 2, then the first path, one which is having 1, will be chosen, and whenever that next hop is going down, it will be going to the next path. That is how we will be configuring. So those details you can see in that Cybex CCNA study guide. Anything else? Okay, Rashmi. So that's it for like routing protocols.
Yeah.
I think we can stop it for today.
Yeah. Okay, guys. You guys don't have any other questions, right?
Like they can refer the CCNA book and come back with some doubts.
Mo, do you have any questions or suggestions?
No, thank you. I'm actually okay with that. We don't really use a lot of things like that here, so no, we're okay.
We do use BGP in our network.
But only for the India and here, but besides that, it's point to point.
I think now we are using BGP. Like in our edge router, we are configuring BGP.
Yeah. So,
on the new one, on the
for
Phoenix?
your knowledge, yes, we are using BGP between Hurricane and Cogen for our network right now.
I got you. I'll take a look of it and I'll see what I can do about that. But that's okay. I'll check it out.
Yeah. Okay, guys, we will wrap the session, and I will communicate regarding the next session and the topic. Yes. Okay, then. Have a great day.
Thank you, guys.
Thank you. Thank you. Bye.